My name is Jiyoung Lee. I'm one of the professors here at CNSC, and this grant will allow us to look at Moore's Law in a very different way. So Moore's Law describes this exponential increase in transistor count with time. And the way this has been enabled is by shrinking the transistor, the fundamental unit of a computer chip. Now, as the transistor approaches the atomic scale, it's becoming very difficult to continue to shrink it. So another way to continue Moore's Law is by stacking the transistors vertically. One way to look at this is to look at the analogy between living in suburbs versus living in cities. In suburbs, you build houses at the ground level, and you don't see many high-rises. And that's similar to how we've been building our transistors. We've been building our transistors on the surface. And the only way to increase the density is by making the transistors smaller. In contrast, in cities, you build high-rises, and living quarters are stacked on top of each other. And you get a very large density of population in cities, and we're trying to emulate that by stacking the transistors. And we'll fund several graduate students and postdocs, and the students will be at the forefront of research. They will be exposed to the 300mm fabrication facility. We'll be integrating novel materials in our 300mm line, and start to exploit the vertical dimension to enable Moore's Law in a different way. We're very excited that we received this grant. It's a privilege to be able to do fundamental research.